Sample final, Chem 110A, question number 4. How many grams of calcium phosphate can be made from 23 grams of calcium chloride and 35 grams of sodium phosphate? The other product is NaCl. There's no equation that's given, and if we're making something from things and there's another product that's formed, that means a reaction is going on. So reading the question, you need to be able to recognize the calcium chloride and the sodium phosphate are reactants, and the calcium phosphate and sodium chloride are the products. You also have to be able to recognize that this isn't balanced, and the way to get it balanced is to decide that that is the most complicated molecule, so we'll assign it a value of 1, which means you need 3 calciums, which means you need 6 chlorines, which means you need 2 sodium phosphates, and the 2 phosphates balance as well, so now that's the balanced equation. So now that we have the balanced equation from the wording of the problem, let's take a look at what we have and what we're trying to find. How many grams of calcium phosphate are what we're asking about. If we start with 23 grams of this and 35 grams of this, that means we have different amounts of both reactants. That's a limiting reagent problem. The way we do those, same every way, same every time. 23 grams of the calcium chloride may be the reactant that completely gets used up, or 35 grams of the sodium phosphate may be the reactant that gets used up. We go through the same process every time. Get to the mole-to-mole ratio. Well, how do you get to moles from grams? The same way every time. We use the periodic table and the molar masses. Moles on top, grams on the bottom. We look this up. It's 110.99 grams, 1 calcium and 2 chlorines adds up to that much from the periodic table. Cancel something out from before. You should be used to this because the first 3 problems here, you've done this 1, 2, 3, 4 times. We're going to do it 2 more. Now that we're at moles of calcium chloride, the ratio here between what we want and what we started is 1 to 3. Canceling out something from before. Once we're at moles, we want mass in grams. We use the mole-to-mole ratio of the balanced equation. To get from moles to grams, we use the periodic table again, making sure our units cancel out. How do we go about that? Grams has to be on top, moles has to be on the bottom, and whenever you add up 3 calciums, 2 phosphoruses, and 8 oxygens, you get 310.18 grams of the calcium phosphate for 1 mole of the calcium phosphate. So, whenever you do your math here, you end up with 21 grams possible if all 23 grams of calcium chloride reacts. But you don't know that that's the right answer because you have to do the other calculation. There's different ratios and there's also different molar masses, so you have to do the work. But it's the same exact work, just different values. Okay, so 1 mole of sodium phosphate. We're starting with mass in grams. We need to get to moles so that we can look at the mole-to-mole ratio. We're using the periodic table 3 sodiums, 1 phosphorus, and 4 oxygens adds up to 163.94. Okay, that allows us to cancel out the grams from here. Once we're at moles, the ratio is 1 to 2 this time. Excellent. Once we're at moles of calcium phosphate, we're using the same molar mass because it's the same stuff. Calcium phosphate per 1 mole. And our result with this calculation to 2 sig figs is 33 grams. You can't make both 21 and 33 grams. You can only make the smaller amount. That's a test calculation. You want to practice this some more. 7b for balancing equations. 7h and 7I for doing mass stoichiometry calculations and limiting reagent problems. Have at it. Good luck.